Good afternoon, Algebra II students. In this video, I will be demonstrating how I would complete the Algebra II Regent if I were in your position. So, this will demonstrate what skills they're testing, what formulas you either need to know or that you don't have to have memorized but need to know how to utilize because it's given on the Regent reference sheet. And I'll be giving tips for each question as I go. The first question it asks, which average rate of change is greatest? So something that is not provided on the Regent reference sheet is your average rate of change formula. You know an average rate of change is a difference in output over a difference in input. If you memorize that as the slope formula, you know that's m equals y2 minus y1 over x2 minus x1. But conventionally, we show it as the difference in y, or the difference in f, over the difference in x. So, let's say f of some input b minus f of some input a over the difference in those two inputs. So, they give us 4 different intervals, and we're going to have to find the average rate of change of each of those intervals. So, number 1, and let's separate the paper just so we know we have enough space for each. So, number 1, 1850 to 1910. We have 1850, we have 1910. We're going to do the difference in output over the difference in input. And we could put this in our calculators. If you want, you could put the whole thing in your calculator, as long as you put parentheses around your entire numerator and your entire denominator. What you could also do, you could simplify your numerator, you could simplify your denominator, and then divide the two. So right now I am putting that on my calculator. And I get 487.18333. I'll put a bar because it's just repeating. For number 2, we're going to do the exact same thing. We're going to do 1990 to 2010. Difference in output over difference in input. You get 14,805. So already we know number 2 has a faster average rate of change than number 1. Number 3, we're going to do the same thing for 1950 to 1970. You get 5,967 0.45. And lastly, option number 4. We are going to do the average rate of change of 1890 to 1970. You get 2,965.4125. The greatest of all those average rate of change is number 2, from 1990 to 2010. So then number 2, which expression is not equivalent? Not equivalent. So immediately I'm looking at this expression, and I see a difference of perfect squares. Remember, if you have a squared minus b squared, that's the same as the conjugates. Different signs, but the terms are the square roots of those terms in the order that they're shown. So a squared minus b squared is just a minus b times a plus b. So we have a difference of perfect squares, so we're going to have different signs. And then the square root of 36 is 6. Square root of x to the 6, x to the third. The square root of 25 is 5. The square root of y to the fourth, y squared. Immediately I see that option number 2 is equivalent, and we're looking for not equivalent. So now, let's look at our other options. 6 squared is the same as saying 36. X to the third to the second power. If you have an exponent within an exponent, you can multiply exponents. So x to the 3 times 2 would be x to the 6. Minus 5 squared is 25. Y to the second would be y to the fourth. That is the same, so we could cross out number 1. For this one, we have 3 times 2 is 6. So we have 6 times x to the third minus 5y to the third to the second times 6x to the third plus 5y to the second. That's the same. You could cross out number 4. So your answer must be number 3. For number 3, I'm seeing an even number of terms, so we're going to do factoring by grouping. Remember, you must include that negative, but you can't magically get multiplication, right? So what we're going to do is to keep this the same as it was before. Adding a negative is the same as saying subtracting. So we have to keep that as addition, not somehow just get multiplication. And then we just have to factor out the GCF, the greatest common factor, of each group. So the first group, x squared goes into x to the fourth and negative 9x squared. So I'm going to pull out the x squared, and I get x squared minus 9. 3 goes into 3 and 27, and x goes into x and x to the third. So I could pull out 3x. And now I have x squared minus 9. And now 10 is the greatest common factor, but I want it to be in the same form as x squared minus 9. So I'll pull out the negative. And we have x squared minus 9. So now between those 3 terms, what's the greatest common factor? The greatest common factor is x squared minus 9. So the way I see that is, if I pulled out x squared minus 9, what would be left? And what's left is x squared plus 3x minus 10. Essentially, you're just dividing out x squared minus 9. So now, in the blue, I have a difference of perfect squares, and in red, I have a trinomial. So we're going to have to factor it using those two methods. Difference of perfect squares, you get the conjugates. So different signs, square root of x squared is x, square root of 9 is 3. In the red, we said it was a trinomial, so we look at the product term, and if there's a negative, we know that's different signs. So we have x minus, x plus, and what factors of 10 would subtract to 3? Well, let's think. I know 10 and 1 is a factor. 10 minus 1 is 9, not 3. I know 5 times 2 is 10. 5 minus 2 is 3. So I'm going to have negative 2, positive 5, because we want to get positive 3. That is now factored completely. So we could look for the zeros. I'll show the work for one of them, right? This is like a multiplication problem. So if I said 3 times x equals 0, we know that one of the factors has to be 0, x has to be 0, right? So if one of your multiplicative factors is 0, we know that it equals 0. So we could set them all equal to 0. And if one of them is 0, then that means the whole thing's 0. But notice this. It's the opposite sign from what's shown. So this one would be x equals negative 3. This would be x equals positive 2. This would be x equals negative 5. So we have x equals negative 5, negative 3, 2, 3, which it appears to be number 4. For number 4, if theta is an angle in standard position whose terminal side passes through the point negative 2, negative 3, what is the numerical value of tangent? So immediately, we're hearing points. We know trig is the study of right triangles, so we're going to visualize a right triangle, so why not draw it out? So that point, negative 2, negative 3. We go to negative 2, draw out negative 3, and the point's here. It talked about some angle. We make that angle with the origin, and that angle with the origin is your theta. And let's make a right triangle. Now, this distance, even though the point is negative 2, right, the x value, we know the distance is positive 2. Even though the height, the y value, is negative 3, we know the height is going to be positive 3. And we're trying to find tangent of theta. So, remember, with trig, the most important thing for you to memorize is so, ka, toa. And which one represents tangent? Toa. Opposite over adjacent. So, the opposite side of theta is 3. The adjacent side is your neighboring side that is not across from the right angle. Remember, the one across from the right angle is your hypotenuse. But that's given. It's 2. So we have 3 over 2. But we aren't done. We have to remember that with trig, we're often working with the reference angles. So we have to see if where it is, it has the correct sign. So we have to remember, all students take calculus. So in this quadrant, only tangent is positive. Did we find tangent? Yes. So we keep it positive. Answer is 3 over 2. Now for this question. It says the average monthly temperature T of M in degrees Fahrenheit over 12-month period can be modeled by T of M equals this function, where M is in months. What is the range of temperatures in degrees Fahrenheit? So we're trying to find how low the temperatures get, how high the temperatures get. Also, if you're using your calculator for a question like this, remember, the only time you're not in degree mode is when you're working with trig functions and you're working in radians. But you don't work in radians if it talks about degrees, right? But what degrees are we talking about? Are we talking about temperatures or are we talking about angles? In this case, you're talking about a temperature. So you could see the regent tried tricking students here. They knew students would see degrees and they would go to degree mode. Remember, we have to be talking about angles in order for it to be in degree mode. And I mean angles in degrees. So if you're using your calculator, you should be putting that in radian mode. But you really don't need to use your calculator for this. You know, with trig functions, and I'll write the most generic trig function you could get, and I'll use cosine since they're using cosine. You know that A is your amplitude, which is just the distance from the midline to either your peak or to your max or your minimum. C is your phase shift, which means is it starting at 0 or did it shift left or right? It's a horizontal shift. And D is your midline. Typically, for a basic trig function, your midline would be 0. But if you're adding, it shifts the midline up. If you're subtracting, it shifts it down. So your midline goes up from 0. So it would be the same as that D value. And then lastly, B is the only one that doesn't directly give you something, but there's a formula that it's included, and it gives you your period, which is just one full cycle. So we're trying to find the max and the minimum, right? And we know the midline. The midline's 56. We know how high it goes above the midline and how low it goes below the midline. So this is a pretty quick calculation. To find the minimum, you would take your midline and you would subtract your amplitude. The amplitude is the positive number, 23. That negative just means rather than cosine looking like this, it reflects over your x-axis to look like this, right? So you could do 56 minus 23, and you get 33. You could do 56 plus 23, and you would get 79. That is your min and your max. That's the range of degrees. If we were graphing this, right, it said that the midline was 56. The min was 33. The maximum was 79. And we said that it reflects over. So this is what your function would actually look like. But it's not asking that. You didn't have to do all that. You just had to find the min and the max. In this case, I always recommend converting two rational exponents first. So we know if you have a to the m over n, the denominator of an exponent is the degree of your root. The numerator is the power shown. So a to the m over n is the same thing as saying the nth root of a to the m. So a to the fifth root of a to the fourth, a to the fifth root of a to the fourth is the same as saying a to the degree of the root is 5, so that's in your denominator. Power shown is 4. There's an invisible 1 on the exponent of the a on the outside. Now you are multiplying by a common base, so you could add your exponents. Remember your power law. If I said x to the m times x to the n, that's x to the m plus n, right? If you're multiplying by a common base, you could add exponents. So we have a to the 1 plus 4 over 5, which you could put in your calculator, or, 1 is 5 over 5, So 5 plus 4 is 9. And that's your answer. If you wanted to convert this back to root form, that would be the 5th degree of a to the 9th, right? Now for this question. I see that letter I, right? And that represents an imaginary number. So we treat I like it's a variable until the very last step, where we could then convert it to our different options, right? And I'll explain the different options after we're done treating it like a variable. So first, let's multiply. 3i times ai. 3 times a is just 3a. I times I is I squared. 3i times negative 6i squared. So negative times a positive is negative. 3 times 6 is 18. I times I to the second is I to the third. We distributed. We treated it like it was a variable. Now remember what I means. I equals radical negative 1. It doesn't make sense to have a negative in a radical. So we denote that by I. It's imaginary. But what if we had I squared? That's like saying radical negative 1 times radical negative 1, which is just like saying the square root of negative 1 squared. When you take the square of a square root, that cancels out the square root and the square. So you'd be left with negative 1. I to the third is the same as saying I squared times I. So that's essentially saying negative 1 times I, which is just negative I. I to the fourth is the same as saying I squared times I squared. That's negative 1 times negative 1, which is positive 1. All of these things don't need to be memorized. It will make it easier if you do, but you could go to your mode in your calculator, go to A plus BI mode, and you could verify this in your calculator. One less thing to memorize. And think about it. If you go to I to the fifth, right, it would go straight back to what I equals. So I to the fifth is just I. I to the second would be the same as saying I to the sixth, right? I to the third is the same as saying I to the seventh. It's a cycle of 4. And again, you could also put it in your calculator. So we said I squared is just another way of saying negative 1. I to the third is another way of saying negative I. This is negative 3a plus 18i. Okay. For this question, we know that your basic log looks like this, right? But it shifted to the left. And it looks like it shifted to the left. Your basic log has an asymptote of x equals 0. This asymptote here is x equals negative a. So it shifted to the left a units, right? So if it's shifting to the left, we know horizontal shifts have the opposite sign. And it's a left is your x values. So when we're thinking left, we should be thinking it's the opposite of what we expect. So rather than being negative, it's going to be a positive. So we're looking at positive a, right? So we're not looking at 2 or 4. And also, it doesn't look like we have that point on the, if I just shifted it here, right, it would look like that. But it doesn't look like we have that same x-intercept. So it shifted up a little bit. So if it's shifting up, we're actually doing the same sign because it's a vertical shift. So it goes up, C. Now this here is an end behavior. End behaviors read as x approaches negative infinity, f of x approaches negative infinity. So the left side of your function should be looking like this, right? So is that what's happening on 1? No. Is that what's happening on 2? No. 4, 3, and 4. You could put these in your calculator and your calculator will show it to you, right? If you don't see it, you would do zoom, zoom, fit. But if we want to think about this logically, we have a negative exponent. So that's essentially saying 5 to the 1 over 4 to the x, which is exponential decay. Exponential decay looks like this. Is your function doing this on the left side? No. So your answer has to be 4. But let's think about why that would be. And again, you could just put these in your calculator. Your basic log function looks like this, right? But there's a negative x. When you negate x, it reflects over the y-axis. So that's going to look like this. But then we're negating the entire function as well. So when you negate the entire function, you're negating y. That reflects over the x-axis. So your final transformed function would actually look like this. So does that look like the same end behavior? It does, right? The arrow faces the same direction. As x approaches negative infinity, right? As x approaches negative infinity, f of x is approaching negative infinity. For a question like this, for the Algebra II Regents, they don't typically give you regular trinomial factors. They try to spice it up a little bit. So you could think of it as a regular factoring problem, right? Usually we just see x. We have a negative sign, so it would be different signs. What factors of 24 would subtract 2? Looks like it would be 6 and 4. We want it to be negative, so it's negative 6, positive 4. But the problem is, instead of x, we had this. So you could actually just replace x with that. Rather than having to do, substitutions, right? Just treat it like the trinomial. So first step, there's a negative. So we have different signs. And then we see that instead of x, you have x squared plus 3. Essentially what I just said, but rather than doing a substitution, you could just substitute it in there. And then what factors of 24 subtracted 2? Again, we said 4 and 6. We want it to be negative 2, so it's going to be negative 6, positive 4. Right? That's where the negative 2 is. Nothing's happening on the outside of these parentheses, so you could drop them. And 3 plus 4 is 7. 3 minus 6 is negative 3. And it looks like that matches option 2. Now we have a system of equations question. Remember, for 3x3 systems, we use elimination. With elimination, there's 2 rules. The first rule is you are allowed to combine equations by addition or subtraction. The second rule is you could multiply equations by a scalar factor, meaning you could just multiply by a number. Our goal is to eliminate variables. So I like to label my equations first. And we have quite a few approaches we could do. We could eliminate x, which would be easy because you could just subtract the equations, any of them. X minus x is just 0, eliminates. So that's one thing you could do. Or, what looks even easier, you can just add equation 1 and 2. Z would cancel out because already 1 is negative. And then add equation 2 and 3. So that's what we're going to do. And I like to write down what I'm doing. So equation 1 plus equation 2. We're eliminating the variable z. So right now I'm writing down equation 1. Now I'm writing equation 2. When I add those, x plus x is 2x, y plus negative 2y is negative y, z plus negative z cancels out, 2 plus negative 4 is negative 2. And I'll call that equation star. Now we're going to do the same thing, but we have to use equation 3. We also have to cancel out variable z, because we want a 2 by 2 system. 2 equations with the 2 same variables. So it looks like I could add equation 2 and equation 3, because we have a negative z and a positive z. So I'm just going to write down those 2 equations. And add them up. X plus x is 2x. Negative 2y plus negative 9y is negative 11y. Negative z plus z cancels out. Negative 4 plus negative 18 is negative 22. And I'll call that equation triangle. Now we have a 2 by 2 system. And again, there's 2 things we could do. You could either combine, and the easiest thing to do here would be subtract the 2 equations, and 2x would cancel out. Or, just so I could show you that other thing that you could do, you could multiply by a scalar factor. So, if I multiply by negative 11, I would get positive 11y. It would cancel out. So that's what I'm going to do. I'm going to do negative 11 times equation star plus equation triangle. So negative 11 star, let's do that quick. Negative 11 times the entire equation star. I accidentally put that a parenthesis on the left side. There we go. So when you do the one side of the equation, you have to do the other. So you have negative 22x, positive 11y, positive 22. So let's write down those 2 equations. Negative 11 star is negative 22x plus 11y equals 22. And equation triangle was 2x minus 11y equals negative 22. Add those up. You would get negative 20x equals 0. Divide by negative 20 on both sides. X equals 0. We could cross out option 1, cross out option 2. Now we're going to plug into one of our 2 by 2 systems. So I'll plug into equation star. 2 times 0 minus y equals negative 2. So 0 minus y equals negative 2. Negative y equals negative 2. Divide by negative 1. Y equals 2. So we get 0, 2. And we still don't know z yet. So we still can't cross out 3 or 4. And now, lastly, we just have to plug into one of the equations. I'll plug into 1. So x is 0, y is 2, we said, plus z equals 2. So we have 2 plus z equals 2. Subtract 2 on both sides. You get z equals 0. So that's our answer. We get x, y, z equals 0, 2, 0. Now that is how you would solve it algebraically, and sometimes the regent does ask you to solve algebraically. But since this is a multiple choice question, something that you could have done was just plug into multiple equations and see which ones would be correct for all three, right? Some might be correct for only one, but they have to be correct for all three. Okay? Now let me erase that just so we have room for these other questions. And I'll erase all of it so you see that we did have work at one point. Okay. For this question, look at the solutions. They are imaginary solutions, except for this one. This is just irrational, but it's still real. So you're probably going to have to use quadratic formula, right? If you have imaginary solutions, that means that it's not factorable. So regardless of if you're factoring or not, you have to have the equation set equal to 0. So add 13 on both sides. Now we're going to use quadratic formula. This is given on your Regent reference sheet. X equals negative b plus or minus radical b squared minus 4ac over 2a. I recommend listing out your a, your b, and your c. Your a is that invisible 1 in the front. Your b is that negative 4. Your c is that 13. Do not include the variables, do not include the exponents. It's just the coefficients and constants. So x equals negative, and I'm going to make a little mistake here, okay? And I'll explain why this is a mistake. Just because I do see students make this mistake often. I accidentally didn't make the mistake on a few terms. So the mistake I made, I didn't include parentheses when I plugged in. So since I'm plugging in a negative, that negative 4 squared, if I put that in my calculator, I'm going to get negative 16. You're plugging in negative 4. You're not plugging in just 4. So when you plug it in, you want to get the square of a negative, which would be positive. If you did negative 4 squared without parentheses, that's negative 16. You want to square the negative as well. So negative times negative 4. So always include parentheses. Even if it's not negative, it won't be incorrect if it's not negative, the b. But it could potentially be incorrect if there is a negative b. So just don't make that mistake. Just always use negative. Always use parentheses. So I'm going to put everything in my the radicand in the calculator. So negative 4 squared minus 4 times 1 times 13 is negative 36. So some of you might see it immediately, but there's a negative 1. There is 36. Square root of negative 1 is I. Square root of 36 is 6. So it's 6i. And then 4 divided by 2 is 2. 6i divided by 2 is 3i, so we get 2 plus or minus 3i. Okay. So now, for this question. Now, I taught you 3 ways of solving this question. One of them would only work if all your options have different remainders, which they do. So technically, you could use your remainder theorem in this case. The remainder theorem says you could set your divisor equal to 0, and then if you plug that into the equation you're dividing from, that would give you your remainder, right? So that's a really quick, easy way to get the answer. But it only gives you the remainder, it doesn't give you the quotient attached to the remainder. So, the other 2 ways I taught was polynomial long division, and I taught synthetic division. Synthetic division you could only use when the leading coefficient is 1 and the highest degree of the divisor is 1. The highest degree of the divisor here is 1, but the leading coefficient is 2. So we have to use polynomial long division. So I'm going to do 2x plus 4 goes into 2x to the third plus 2x minus 7. And notice I left a little space. There's a reason for that. You have your third degree term. You have your first degree term. You have your 0th degree term. But you're missing your second degree term. So we have to include your placeholder 0. So 2x goes into 2x to the third, x to the second times 2x times x to the second is 2x to the third. 4 times 2x squared is 4x squared. Subtract that whole term, meaning you need parentheses. 0 minus 4x squared is negative 4x squared. Bring down the 2x. 2x goes into negative 4x squared. Negative 2x times. So we're going to distribute that number now. So negative 2x times 2x, negative 4x squared. 4 times negative 2x, negative 8x. Subtract that whole term. First term cancels out. 2x minus negative 8x, you could do keep change. 2x plus 8x is 10x. 2x goes into 10x 10 times. That is incorrect. It goes into it 5 times. Oh no. Two x goes into 10x 5 times. Bring down the negative 7. 2x times 5 is 10x. 4 times 5, 20. Subtract those. Negative 7 minus 20, same as saying negative 7 plus negative 20, negative 27. That's your remainder. So you could subtract your remainder over the divisor. Your answer would be number 1. Again, if you were to use the remainder theorem, what you could have done, you could have set your divisor equal to 0, solved. Then you could have plugged in whatever that solution is into what you're dividing from, and you would have gotten negative 27, and you would have known your remainder. A lot of time on the Regent, though, they give you more than one option with the same remainder, so that you can't use the remainder theorem. Okay, for number 14. Immediately I see that it says exponential regression equation. It says, according to the model, about how many followers did she have in June 1st, 2018. This says the number of months since January 2015. So January 2015, this would go to January 2016, 17, 18. So from here to here is plus 12 months. Plus another 12 months. Plus another 12 months. Now it says June. So I'm going to count this on my fingers. So we go from January to February, March, April, May, June. Another 5 months. So that's the same as saying 36 plus 5, which is 41 months from January 2015. So already we had to solve for how many months, right? Now we have to create an equation, because I don't see 41 months on here. I mean, you could try to go in between, right? But let's get a little bit more accurate. So, in my calculator, let's do an exponential regression. So, I'm going to go to Stat Edit, and I'm going to, in my L1 list, I'm going to put in all my inputs. 2, 11, 16, 20, 27, 35, 47, 50, 52. In my L2, I'm going to put my outputs. 3.1, 7.5, 29.7, 49.7, 200.3, 680.3, 5,200.3, 8,109.3, 12,107.1. Check over your numbers. It's very common. Students accidentally type the wrong number in. Go to Stat, go to Calc, and we're going to go to XReg. So it's not shown on the screen, but you could scroll down to XReg. Make sure X list is L1, Y list is L2. Nothing's in your frequency list. Press Calculate. And it gives you the formula Y equals A times B to the X. Just write those numbers in. So we have Y equals A is 1.76, 795,716, times B, 1.184, 1601. It is to the X, right? But we already said X is 41 months, so we could say it to the 41. Now let's put that in our calculators. So 1.7679. You could round. It's just the less you round, the more accurate this will be. 1.18483 1601 to the 41. And what I end up getting in my calculator is 1,850.945032. But look at that. It's the number of social media followers in thousands. So 1,000 is a million, right? So technically you can move this over to the right 3. And that would be 1,850,945.032. You can't really have a decimal of a person. Closest answer would have been 3. Okay. For number 15. Luminescence. For questions like this, they just want you to be able to manipulate your exponentials and your exponents. So this is the same thing as saying I0 or I naught times e to the 3 times -1 over 0.6 times t, right? So let's do that. 3 times negative 1 divided by 0.06. I'm sorry, 0.6. You get negative 5. So that's the same thing as saying I0, or I naught, times e to the negative 5t. Immediately we could see this isn't negative, so we could cross out 2. But we know that negative 5 would be the same thing as saying pushing the e to the denominator, right? So that would be I naught over e to the 5t. But that's not really a form that's shown. It's not an incorrect step, but it's not shown. But I see decimals, right? So clearly they expanded the growth rate. So we have e to the negative 5 to the t. Let's see what e to the negative 5 is. If you don't know where e is on the calculator, it's second divide. You end up getting I naught times 0.006737947 to the t, which is approximately option 3. For number 16, I see normal distribution. So, we know we could use normal CDF. You just have to remember that it is lower, upper, mean, standard deviation. So, your mean, 68.1. Standard deviation, 3.4. And we're trying to find the percentage of students with a height less than 60 or greater than 75. So first let's focus on the percentage of students less than 60. If it's less than 60, 60 is your upper, right? And then what's the lowest height a student could be, right? I'm not going to have a student that's 0 inches. That doesn't make sense. Unless the student doesn't exist, right? But you're also not going to have a student that's a negative height. So what percentage of students are 0 inches or negative? 0%, right? So if you're adding 0%, that's not going to affect that amount at all. But imagine out of these students, we said there were no students that were 49 inches. But what if there was a student that was 49 inches? They wouldn't be included. So I like to use extremes. And we said or students greater than 75 inches. So we're going to have to do another normal CDF. And greater than 75. So 75 is your lower. And what's an impossible height but higher than 75? Let's say they were 1,000 inches or 10,000 inches. It's not going to change it. Same mean, same standard deviation. We're going to add those two up. So on my calculator, I do second vars, normal CDF, negative 100, 60, 68.1, 3.4, paste that in. I'm going to add that with, I'm going to do second vars again, normal CDF, lower is 75, upper is, I said, 10,000, and then same mean, same standard deviation, add those up. And what I end up getting when I find that sum is 0.029809304.7. And to convert that to a percent, that's 2.9809347%. It's approximately 2.98%. Okay. Marissa and Sydney. are trying to determine if there is enough interest in their school to put on a senior musical. They randomly surveyed 100 members of the senior class. 43% of them said they would be interested. Marissa and Sydney then conducted a simulation of 500 more surveys, each of the 100 seniors assuming that 43% of the senior class would be interested in being in the musical. The output of the simulation is shown below. The standard deviation of the simulation is closest to. So, something you can do, but it would take you forever, would be to count all of these. It looks like it's going up by 0.01. Put that in your calculator, right? You go to stat, go to edit. You would make your L1, your options. That would be 0.28 to 0.60, all by 0.01. So that's a lot of options. And then you'd have to count all of these and put that in for L2. You'd put in your frequency list, L2, right? And then do first var, stat, and that would give you a pretty close estimate, right? But what you have to think to yourself, what's a formula that we had that had standard deviation in it? What I'm thinking of is the middle 95% interval, which is your mean plus or minus 2 standard deviations. So, counting 95% of the data, that would take you a while for 500. But what wouldn't take you a while is 5%, that extra 5%. So, let's do, she did 500 in the simulation, right? 500 more surveys. So let's find 5% of 500. You end up getting 25. So you could already kind of immediately pick out the outliers that would be out of the middle 95%, right? Like this is definitely an outlier. These are probably outliers. These are probably outliers. So let's start counting on the outside. So I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So 23 is close enough for 25, right? So you have your middle 95% interval, that means. What you have is, it looks like it's going by 0.1s. 28, 29, 30, 31, 32, 33, 2, 52, 53, so 0.53 I would say. So that's about your middle 95% interval. And your mean, when we used to draw this, before we started using our calculators, and before we used the z-score chart, we used our bell curve, which is a normal distribution. And we said that this is your mean, the middle. So your middle, about here, 0.44 would be the mean. So, 0.44 minus 2 standard deviations will equal about 0.33. Right? I used the negative, so that's your left bound. If I would have done the positive, we would have used a right bound, 0.53. So, what we're going to do, subtract 0.44. Divide -2. You get 0.055. It's about 0.05. We solve for our standard deviation. They don't often give questions asking for the standard deviation, but they do give middle 95% interval questions a lot. So make sure you know how to work backward, right? It's kind of like a puzzle on some questions. Okay. So now I'm seeing a lot of even, odd, right? And if it's an even function, if you plug in a negative, you get the same output as if it was you plugged in a positive, right? If it's odd, if you plug in a negative, you get the same value, but it's going to be negative. So it's the negative output. So you could remember if cosine or sine are odd or even, right? But if that shifts it at all, that completely changes it. So I recommend knowing these rules and being able to plug in. So let's read the first option. 2 of f of x and f of 2 of x are even functions. So 2 of f of x would be 2 times cosine of x. And we said if you plug in a negative, you're going to get the same as if you plug in a positive. So let's see if that's true. I'm going to plug in a random value. Let's say we know, if we think about the units, and again, you don't have to memorize this. If you want, you could use your calculator, right? But I know from the unit circle, cosine of 60, cosine's your x value, right? Cosine sine. So cosine is that first 3, 2, 1. So cosine of 60 would be 1/2, right? So let's plug in 1/2 for x. Not 1/2, I'm sorry, cosine of 60. So let's plug in 60 for x. For 2 times cosine of 60, you're going to get 2 times 1/2, right? Which is just 1. And now let me do, and I'm in degree mode, right? Yeah. Because 60 degrees I'm talking about. 2 times cosine of negative 60. I get 1. Does 1 equal 1? Yes. It's not negative, one of them, so it's not odd. It's the same value, so it's even. So 2 of f of x is even. That's correct. Now let's check f of 2 of x. So cosine of 2 of negative x should equal cosine of 2x. Now, we just said cosine of 60 is 1/2. So let's do cosine, let's make x 30 so that it's 60. So cosine of negative 60, so we're saying where x is 30, cosine of 60, cosine of 60 is 1/2. And again, you could put these in your calculator. You don't even have to use the famous angles. You could use random numbers and see if that's the same number in your calculator. But if you know them, you might understand it better. Cosine of negative 60, let's check that. If I didn't want to put it in my calculator, I could find the coterminal angle. Could add 360 to 60, you get 300. Find the reference angle, create a right triangle, find cosine of that value, and then I could do all students take calculus and see if it's positive or negative, right? But I didn't do that. I did it in my calculator. 1/2 equals 1/2. That's even. Number 1 is correct. Perfect. If we had more time and I wasn't simulating if we were taking the regent, I would go into each option with you. Now we have rational functions. For rational functions, you don't want to have denominators, right? So let's cancel them out by multiplying by all the denominators. And you're going to distribute that out. The first term, x minus 5 cancels out, so you would be left with x plus 3 times x plus 2. The second term, x plus 2 cancels out, so you'd be left with 6 and x minus 5. On the right side of the equation, both cancel out, so you'd be left with just the numerator. distribute those out. X times x is x squared. 3x plus 2x would have been 5x. 3 times 2 is 6. 6 times x is 6x. 6 times negative 5 is negative 30. Combine like terms. X squared. 5x plus 6x is 11x. 6 minus 30 is negative 24 equals 6 plus 10x. We have this quadratic, right? We want it to equal 0, so minus 6 on both sides, minus 10x on both sides. So we have x squared. 11x minus 10x would be 1x. Negative 24 minus 6 would be negative 30 equals 0. You could use quadratic formula, or you might be able to factor, so let's try to factor. We have a minus sign here, right? So different signs. What factors of 30 subtract to 1? 6 and 5. It's positive. So we're going to have positive 6. So your solutions are very clearly negative 6 and positive 5, right? But wrong, right? With radical and rational functions. So if you have a square root function, square root symbol, if you have a fraction as a function, we have to check for extraneous solutions. So we look back at the original function. Let's look back at the original function. And when we look back, when you plug that into any of the denominators, would that give you 0? If I plugged in 5 there, it would give me 0. You can't divide by 0. That's wrong. That would be extraneous. Now, what about this? What denominator would make that 0? What would that, if we had a denominator there that made negative 6 0, it would be x plus 6. Do we have x plus 6 anywhere in the denominator? No. So your solution is x equals negative 6. You have to remember to check for extraneous solutions. Look, if you didn't, you would have thought that this was your answer. It is not. Okay? Something else you could do. Put this in your calculator. Make sure you put it in your calculator correctly. Right? Put this in your calculator, right? This will be your y1. This will be your y2. And then do second trace intersect. Find the point of intersection. That's something else that you could do. Okay. So for a question like this, the best way to show this, convert to rational exponent form. So we know that y is in the denominator, so that y to the first would actually be y to the negative first. So let's check out the rest. We have a negative 1. Negative 1 as an exponent becomes 1 over y over x to the third. Keep change flip. 1 times x to the third over y. That's x to the third over y. It's the same thing. So that's equivalent. What about this one? You have, remember, if we had x to the m over n, I believe we did it in this video. This is the degree of the root, this is the degree of the power. So that's the same as saying the nth root of x to the m. So this is the same as saying x to the 9 over 3 times y to the negative 1. What's 9 divided by 3? 3. Look at that, it's the same. So it could be just be 1 and 2. Now let's check this one out. X to the 6 times y to the 8 over 4 over x to the 3, y to the 3. X to the 6, 8 divided by 4 is 2. X to the third, y to the third. Remember, if you're dividing by a common base, you could subtract exponents. So we have x to the 6 minus 3, y to the 2 minus 3. X to the 6 minus 3 would be x to the third. 2 minus 3 would be negative 1. It's the same. It's 1, 2, and 3. Okay. For number 21. We've been doing this for a while, so hopefully we're not on number 2. We're finding the inverse function. So we want to find the inverse of this inverse. All I did was rewrite it. First step, switch x and y. So we're going to switch x and y. So when you switch x and y, we could subtract 1/6 on both sides. We could multiply by the reciprocal on both sides if we want. You could also multiply by 3 and then divide by 2. It's the same thing. So, distribute that out. 3 over 2x minus 3 times 1 is 3. 2 times 6 is 12. Could simplify that. 3 over 2x minus 1/4 y equals. That was the original function, f of x. The inverse of the inverse. So your answer would be number 3. For these identities, it's going to be really annoying to prove, right? If you really wanted to prove it, you could try to simplify each of these, right? as most as you can. And that would be probably something that I would do. But if I were you, I would not be doing that. Something that's so easy that you could do. Just give a value to x, give a value to y, plug in. So let's say the value is, I don't want to use 1, don't want to use 0. 1 and 0 are identities. 0 is your additive identity, 1 is your multiplicative identity. What happens with identities, it's very common for things to cancel out and then for it to be the same. So we want to use uglier numbers. Let's say x is 3, y is 7, right? I'm going to plug that in on my calculator. So first, you're going to have to do it 6 times. 1 for the left, always for the left-handed side, and then always for the right-handed side. So first for the first one, 3 squared plus 7 squared. You get 58. Now I'm going to plug it in to the right side. So 3 squared minus 7 squared plus 2 times 3 times 7, all of that in parentheses squared. You get 1,724. Is that true? No. This does not work for all numbers. Now this one. 3 to the third plus 7 to the third. You get 370. Let's see if that equals the right side. 3 minus 7 in parentheses plus parentheses 3 squared minus 3 times 7 plus 7 squared. You get 33. Is that equal? No. This one doesn't work either. Let's see if the region really is trying to trick us here. 3 to the 4th plus 7 to the 4th is 2,482. Let's see if that equals the right side. 3 minus 7 times 3 minus 7 times 3 squared plus 7 squared. Get 928. None of these are identities. They don't work for all numbers. So 0. Okay? For 23, it says, if the focus of a parabola is 0, 6, I like to draw things out just so you guys could visualize it a little better. If that helps you, do that. So, directrix is 4. 3, 4. That little straight line, right, is your directrix. The focus is at 0, 6. Your vertex has to be in the middle of those two. So that would be 0, 5, your vertex. And your parabola can't go through the directrix, so we know it's concave up. So that's what it looks like. And I did teach you guys how to find it using the locus definition, but something that I think you guys probably should do for the regent, just know the formulas. And also, this one's actually a bit easier because you could kind of just weed it out, right? If your vertex is 0, 5, attached to x should be 0. So it has to be either 2 or 4. And then attached to 5 should be negative 5. Attached to y should be 5. So that would be answers number 2. So we could have just went based off the drawing, right? We can't always go based off the drawing. So let's go off based off the formulas. Conic form of a parabola, 4p times y minus k equals x minus h squared. We know the vertex is just hk. The focus would be hk plus p. The directrix, that line, is y equals k minus p. Right? So, something that you could do, you could plug in that. We already said attached to x is 0, so it'll be x squared. Attached to y is 5, y minus 5. And we don't know our p yet, right? But we do know our directrix. Directrix is 4p. I'm sorry, directrix is y equals 4. So, we could just start plugging in. So, directrix is 4, y equals 4. Our k, remember, that's your vertex. So, hk is your vertex. So, 5 is your k. Minus p. You could subtract 5, get negative 1. Divide negative 1, and you get p equals 1. So, 4 times 1 is just 4. So you have 4, y minus 5 equals x squared. And that's why the answer is number 2. Okay? Lastly, we have this question. It looks like from the options, it's probably going to be a geometric series, right? Because it looks like the geometric series formula. But let's see. John and Margaret deposit $500 into a savings account for their son on his first birthday. So the first year is $500. They continue to make a deposit of $500 on the child's birthday. So the next year it would be, $500 plus the $500, where there's an annual interest rate of 4%. So it's growing by 1.04, right? And so on. Since this is the series, right? Obviously, if you wanted the sum to be part of each year, you could just add the 500 to this. But it's a series, so why would we do that? Let's just put what he's making each year, right, all the way to the last year. So then it would be, 500 to 1.04 to the second plus dot 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 plus. And I would start it as a sequence, but we could show it as a series if we want. Remember, the only difference is sequence is a list with a pattern. Series is when you add up the terms of that list. So it's going to go all the way up to the last year would be the last 500, right? And this would have been accumulated for, what is this, 21. So 20 years, right? So this would actually be the amount he made in the first year. This would be the amount he makes in the last year, because the last year didn't get 20 years of interest. So the first term, remember, your geometric sequence is geometric because it's a common ratio. is a sub 1 times 1 minus r to the n over 1 minus r. First term we could say is 500. 1 minus it grows by 1.04 over 1.04. And it goes to 21 years. So that's why it would be 21 in that case, right? Because we're counting that 500 as part of it. So your answer would, in fact, be number 2. Okay? And that formula is actually given on the reference sheet, by the way. It's written a little bit differently. On the reference sheet, it's written like this. A sub 1 minus a sub 1 r to the n over 1 minus r. What they did there, they distributed out the, the a sub 1. Okay? So that's the multiple choice on this region. Times 421. Okay. So, should I pause this and then we could do it? I could combine the videos. Let's see how much time it takes us. It's only 11 more questions. So, the business office of a local college wishes to determine the method of payment that will be used by students when buying books at the beginning of a semester. Explain how the office can gather an appropriate sample that minimizes bias. So, when you want to minimize bias, you want to minimize self-selection, minimize and randomize as much as you can. So, business office. Okay. So what you could do is a survey, right? Do a random survey. Oh, always try to use the word random somewhere in there. A random survey of every 5th customer entering the bookstore of the college. That way it relates to the student of the college, it's randomized, and you are not selecting the student. Right? It's a pretty good answer. Now we have a radical function, so remember, you have to check for an extraneous solution when you do this. You isolate the square root, which it already is. Square both sides. Whoops. Expand. X times x squared. Negative x, so negative 2x. Positive 1. Get that quadratic equal to 0. Okay. See if you could factor it. Different signs, right? 6 minus 1 is 5, right? We want it to be negative 5, so negative 6, positive 1. The solutions, as of right now, are negative 1, positive 6. Are we done? No. We have to plug back in to check for extraneous solutions. So, did I erase? Yeah, I erased too much. Okay. So, plug that back in. Check. X equals negative 1, x equals 6. Square root of 3 times negative 1 plus 7 equals negative 1 minus 1. Square root of 3 times 6 plus 7 equals 6 minus 1. So, square root of 3, I'm doing this in my calculator, 3 times negative 1 plus 7 is 2. Negative 1 minus 1 is negative 2. Not the same. Extraneous. Let's do the same thing for 6 now. Plug in 6 instead of negative 1. You get 5. 6 minus 1 is 5. That's correct. Answer is x equals 6. The population of bacteria, P of t, in hundreds after t hours can be modeled by the function P of t equals 37 times e. Determine whether the population is increasing or decreasing over time. So, something you could do. You could put this in your calculator and see if it looks like this or it looks like this, right? Growth, decay. Or, this is the initial amount. This is the time in years. This is your rate that it's either increasing or decreasing by, right? So, so P of t equals 37 times e to the 0.0532 t, right? This is your rate. So, e to the 0.0532 is 1.0. So that equals 37 times 1.054640552 to the t. Your base is greater than 1, so it must be exponentially increasing. So you could say exponentially grows by approximately, you know that 1 represents the original population, right? This is this part of the decimal is the rate that it's growing by, 5%, by approximately 5.4640552%. Again, you could just graph it and say that the graph looks like that. You could input one value, input a later value, show that it's growing. You know that exponentials are either strictly decreasing or strictly increasing, right? So you could explain that. There's honestly a lot of different answers that you could give. The polynomial function has a factor of x minus 3. Determine the value of a. So they do try to throw in a little bit of a more abstract question here. Remember, you could use your remainder theorem. X minus 3 equals 0. You set the divisor equal to 0. This is what I was talking about earlier. X equals 3. When we plug in g of 3, we want it to equal 0 if x minus 3 is a factor, right? So, we could plug in 3 into wherever you see x, and we want it to equal 0. So 3 to the third plus a times 3 to the second minus 5 times 3 plus 6. And we said we have has to equal 0. So 3 to the third is 27 plus 9a minus 5 times 3 plus 6 is negative 9. 27 minus 9 is 18. Subtract 18. Divide by 9. A equals negative 2. Right? It's not so bad. Write the recursive formula. A recursive formula, you must include the first term. Something I really stressed when we learned this unit. So the first term is 189. Now you want to show a relationship between a term and the previous term, right? And in this case, we want to find some pattern between them. It's probably going to be arithmetic or geometric. Check for either a common ratio or difference. So, if it's a common difference, you would add by that common difference. If it's a common ratio, you're going to multiply by that common ratio. So, we're trying to find that relationship between the term and the previous term. What are you doing to a previous term to give me this next term, right? So to find the common ratio, you take a term, divide by the previous term. 63 divided by 189 should equal 21 over 63 if it's a common ratio, which should equal 7 over 21. 63 over 189 is 0.3333, which is 1/3. 21 over 63 is 1/3. So your common ratio is 1/3. So you're multiplying each term by 1/3 to get the next term. That's your answer right here. Okay. Solve algebraically for x to the nearest 1,000th. Isolate your base, then convert to log base form. Log base argument equals exponent. So your base here is e, right? E to the 0.49 equals 15 over 2. Log base e of your argument or your answer, right, is on the other side of the equal sign. 15 over 2 equals your exponent, 0.49x. You could put it in your calculator as log base e, right? Or something that's easier, log base e is the same as saying ln. You could just click the button for ln. To find for x, you would divide by 0.49. So ln of 15 divided by 2 divided by 0.49 is 4.112046,981 to the nearest 1,000th is approximately 4.112. Okay. It wants you to put this in simplest form. Okay, so let's try dividing it. So we have x squared minus 3x goes into could say we're missing a constant. I don't know if that's going to change it. 2x to the third plus x squared minus 18x minus 9. X squared goes into 2x to the third. 2x times 2x times x squared is 2x to the third. Negative 3x times 2x is negative 6x squared. 0 times 2x would be 0. I'll put 0x so we know that it's the linear term. Subtract those. It would change it, by the way. You should put that placeholder 0. So when you subtract, remember to keep change. This cancels out. X squared plus 6x squared would be 7x squared. Negative 18x minus 0. Negative 18x. Bring down the negative 9. X squared goes into 7x squared 7 times. So this is going to give you your remainder. So x squared times 7x squared is, x squared times 7 is 7x squared. Negative 3x times 7 would be negative 21x. 0 times 7 would be 0. Subtract the whole thing, which is the same as saying keep change. This cancels out. Negative 18x plus 21x would be 3x. Negative 9 plus, or really minus 0, would be negative 9. That's your remainder. Remember, your remainder, you divide that by the divisor. So that's your answer. 2x plus 7 plus 3x minus 9 over 3x minus x squared. Okay, we have this. They give you the mean, they give you the standard deviation. So suppose a sample of 150 students from high school showed that 88% of the students had purchased the apps on their smartphones in the past 3 months. Based on the simulation, would the results from your high school give the app design reason to believe their assumption is incorrect? Okay, so with a question like this, you're always going to find the middle 95% interval. So, middle 95% interval. Take the mean, you're going to subtract, you're going to add your two standard deviations. You could find that information right here. Just plug that in. You get 0.794. When you add the two standard deviations, you get 0.91. So our middle 95% interval is 0.794 to 0.91. 85%. So the app design company believes that it's 85%. A sample of 100 is show that 88% of students, right? Both of those fall within your middle 95%. This is based on the simulation. Would the result from your high school give the app design company reason to believe their assumption is incorrect? No, because it still falls within the usual or the plausible interval. So you would say no. The results from the high school does not give the app design company reason to believe their assumption is incorrect, since both fall within the plausible, remember that word plausible means believable, plausible middle 95% interval. If it didn't fall within that middle 95% interval, then that means that some external factor is driving it to be unusual data or unfair, right? Okay. Patricia creates a cubic polynomial function with a leading coefficient of 1. Okay, we know the leading coefficient is 1, so our a is 1. The zeros are 2, so x minus 2, 3, x minus 3, and negative 6, x plus 6. Write an equation for p of x. That's the equation, right? If it wasn't, you would have a, and if your leading coefficient wasn't 1, you would have a in front. You would need another point, and you would have to plug in to find a. But leading coefficient's 1. The zeros were 2. So 1, 2, 3, and negative 6. So those are zeros. The leading coefficient's 1, right? So a cubic that has a positive leading coefficient looks like that. A cubic, that's kind of bad, looks like that. Oh, what I have is better before. So that's positive cubic. This would be a negative cubic, right? So it's positive since the leading coefficient's 1. So we start in the third quadrant, we go around, and it looks like this. Okay. Public radio station. Table below summarizes the donor category on method of donation. To the nearest thousandth, find the probability that a randomly selected donor was categorized as a supporter, given that the donation was made online. Once you see given, you should be thinking given condition. That is your conditional probability. So P of A given B equals P of A intersect B over P of B. This is something you need to know. So we want to find the intersection of, let's see, that a randomly selected donor was categorized as a supporter given that the donation was online. So we're finding P of S given O. So we're finding the intersection of supporter over online. So the intersection of supporter and online is 1,200. And then online, they don't give the total, so you actually have to add them up. So that's 1,200 plus 2,616. So that is 1,200 out of 3,216. Oh, to the nearest thousandth at once. Okay. So we're going to do that. You got 0.373. Does this data indicate that being a supporter is independent with donating online? So if independent, P of S given O should equal the probability of the event, right? Not the given condition. So P of S given O should equal P of S. Let's check. We said that P of S given O, 0.373. We want to check if that lines up with the probability of being a supporter. So, of being a supporter, you would do 400 plus 1,200 over everyone. So, 400 plus 1,200 plus 672 plus 2016. So that's 1,600 over, usually they tell you the total amount in the question, but they didn't. 400 plus 1,200 plus 672 plus 2016. 4,288. So we're checking if this equals this, 1600 divided by 42,088, you get 0.373, yeah. 0.373 equals 0.373, which implies that P of S given O equals P of S. The two events are independent. The events of being a supporter and donating online are independent. If it would have changed, then they would have been dependent. Okay. So now we have this circle formula, we have this, and we're going to use substitution, right, to solve this algebraically. So we have x minus, we already know what y equals, so we're just plugging for y. X minus 2 squared plus negative 2x plus 7 minus 3 squared. The reason I didn't use parentheses was there was nothing happening to the y on the outside, equals 20. So I have x minus 2 squared negative 2x plus 4 squared equals 20. X minus 2 times x minus 2 plus negative 2x plus 4 times negative 2x plus 4 equals 20. X times x is x squared. X times negative 2 is negative 2. Negative 2 times x, negative 2x, so negative 4x. Negative 2 times negative 2, positive 4. Plus negative 2x times negative 2x is positive 4x squared. Negative 2x times 4, negative 8x. We get negative 8x again, so negative 16x. 4 times 4 is 16. Let's combine like terms. So 4x squared plus x squared is 5x squared. Negative 4x plus negative 16x would be negative 20x. And then 4 plus 16 is 20 equals 20. We want a quadratic to equal 0, so we subtract the 20 on both sides. 5x squared minus 20x equals 0. Factor out the greatest common factor, 5x. You get x minus 4. So you would get x equals 0, x equals 4. And that would be your two solutions. It's not a radical. It's not a rational, so you don't check for extraneous. Okay. Let's hope we don't run out of time here. On a certain tropical island, there are currently 500 palm trees and 200 flamingos. Suppose the palm tree population is decreasing at an annual rate, so you already know it's geometric, so it's exponential. And the flamingo population is continuous, so they're both exponential. And one is going to use PERT, right? A equals P times E to the RT, that's continuous. The finite amount, annual, would be your non-continuous formula. Write the two functions. So let's do the palm tree population first. That's the finite amount. So A equals P times 1 plus R over N to the NT. In this case, the number of times compounded is annual, so it's just going to be 1. So you could just use A equals P times 1 plus R to the T. That's your palm tree, so they want us to use P of X. P of X equals the initial amount, 500, times 3% would become 0.03, right? You move your decimal over to the left too. So it's 1 point. It's decreasing. So it's actually 1 minus r. So we have 1 minus 0.03 to the t, to the x, because they want us to use x. Now for the flamingo one. It's growing at a rate that's continuous. So we use this formula. So f of x equals, started with 200 flamingos, times e, rate of 2%, so 0.02, x. State the solution rounded to the nearest year. Interpret this meaning. So what I'm going to do, I'm going to put that on my calculator. Y equals 500 times 1 minus 0.03 to the x, 200 times e to the 0.02, x, graph that. When I graph it, immediately I see nothing, so I go to zoom fit, and now I see something that looks like this. We could see that the intersection will be about here, so we're going to go to zoom out. I go near the intersection point and press enter to zoom out near the intersection point. Now I see the intersection point. I go to second trace intersect. I go close to the intersection point, enter, and we get that x equals 18.159039. If you want, y equals 287, but the solution is this, 16. So your x is the number of years. So you could say, it says to the nearest year, so after 18 years, the palm tree and flamingo population are the same, with, if you want, this is not needed, with about 287 of both species. But that's just extra information I added. 37, the last question. Are we good on time? Yeah, I'm doing good on time. The volume of air in an average lung during breathing can be modeled by this. Using the graph, write an equation for n of t. So this is, we already said, your midline. This is your amplitude. This indirectly gives you your period. Period equals 2 pi over b. Not on the reference table, you have to know it. So the amplitude and midline are the easiest to see. So, the midline, splitting it directly in the middle. It's going up by what? 200? 200, 400, 600, 800,000. Yeah. So, the midline is at 2,400. So C is 2,400. The amplitude is the space, or the distance, from the midline to the peaks, or the minimums. So that goes up 200, up 400, right? So 400 sine of BT plus 2,400. Now we have to solve for B. Remember, that indirectly gives you your period. So one full cycle goes around, comes back, and then it would restart again, right? So one full cycle starts at 0. So your period is actually 5. So 5 equals 2 pi over b. A much easier trick, you could actually find the reciprocal of both. So 1 over 5 equals b over 2 pi. Multiply both sides by 2 pi. You get b equals 2 pi over 5. So 400 times sine of 2 pi over 5 t plus 2,400 n of t. That's your answer. The same lung, when engaged in exercise, has this graph, e of t. Graph at least one cycle. One cycle, that's a period, right? So let's do that in, let me erase what I put on that graph. Let's use blue for this equation, or I'll use green, okay? So it's a little different. This is your midline, this is your amplitude. We want to find the period. Remember, this is your b. So period equals 2 pi over b. Period equals 2 pi over b. Your b is pi, so period equals 2 pi over pi. So that pi cancels out. Period equals 2. So one full period will be in between these two, right? And we know that in one full cycle, we want to split it into 4 sections. So we're going to divide our sketch point. We would find by dividing our period into 4. So 2 over 4 equals 1/2. So this is a sine function. You start at the midline, right? And we're going to go to 1/2 by 1/2. So the midline we said was 3,200. So that's here. And we're going to go up 2,000 and down 2,000. So up 2,000 would be, well, we start at the midline. Then you're going to go up 2,000 at 1/2. Then you're going to go back to the midline, go down 2,000. And then you're going to go back to the midline. So during exercise, it looks like this. That's one full cycle that we showed. And that's E of t. So let's label that E of t. How many times during the 5-second interval will n of t equal E of t? So if you want, you could show more than one full cycle, right? So on the 5-second interval. So we're going to go up again, down again, down again, up again. It's kind of hard to see on the iPad. So it looks like this. Up again, down again. So it looks like we have 1, 2, 3, 4. We have 4 points of intersection. And that was one full region completed. I hope that helps you guys. We finished in 2 hours. You guys get 3 hours. Obviously, you know, I'm the teacher. And also I'm explaining. So it will take you a little bit more time. But, you know, try your best, study, and you got this.